Welcome back, happy fabricators. In this video we're going to be doing a cast aluminum weld repair on this motorcycle side case. Now I don't think this video is really going to be a how-to video, it's more going to be like a how-I video, because what I found is when doing cast aluminum repairs, every single one is different and I end up learning stuff along the way as well. Not to say I don't have a set of standard operating procedures that I start with and go through, but as you get into repairs like this, there's always variables, and sometimes that changes how I continue to address the problem. So a little bit of background with this project here. This is a side case for a late model Honda CRF 250. It came off of my bike. Unfortunately, I didn't quite get my air intake on all the way, and the thing was sucking fresh air, so it was running really lean, and it made a hot spot right in the center of the piston, punched a hole through it, dropped a piece of hot molten metal down through the piston into the case, and forced that material in between the crank and the case here, then in turn kind of splitting out the case. So it stretched the case just a tiniest bit and it cracked it both right here and right here. The other thing we're going to do is we are not going to use any fancy like machining tools with this. We're going to do this with just die grinders, things that you can do this with in your own shed or shop. We don't need a fancy machine shop to be able to get within the tolerances that we need to make this a usable part again. Okay, so the first thing we're going to do to repair this cast aluminum is cast aluminum by its nature is very dirty and not clean material. And then on top of that, when applications like this, it is submersed in oil. So we have had our clutch fluid in here, and then there's lubricating oil with a 2-stroke. So we want to try to clean this part up as best we can. We're going to remove all our gaskets. I'm not going to worry about removing any of these bearings because they're going to need to be replaced if this side case gets used again anyways. Okay, so now that we got all our gaskets removed and this cleaned up, my favorite method for that is degreaser and a Scotch-Brite pad. Doesn't have to be the industrial Scotch-Brite. You can get your little greenies or whatever. But I find this works well to degrease everything and kind of deoxidize things. Next thing we want to do is we want to heat this thing up so that we can do one of a couple things. One is we're going to dry up the moisture that we've put into it, and two, heat is going to help bring some of those impurities out. So if you've got a shop oven, that can work. Not a lot of people do. I don't have one of those. I have an infrared lamp that I really love to use for that. You can set it out in the sun. It doesn't quite get hot enough when you get out in the sun. Or if it's wintertime, you don't have those options. If you've got a fireplace, you can stick it up on a couple pieces of metal so you're not directly on the fireplace. But I like to warm the casting up to about 150 degrees. We don't want to go much hotter than that because you can potentially start taking away some of the mechanical properties, but it's just enough that it opens the pores up and allows any secretions to start working their way out. Sometimes I'll heat these castings up and you'll get oil that'll start weeping out and other things. So let's dry this thing up and see what we get. Okay, now that we've let our casting warm up, this one is actually pretty clean. I did a really thorough job of scrubbing it down ahead of time. That's something with any of these repairs, especially on aluminum castings. The more due diligence you do ahead of time cleaning stuff up, the easier your life's going to be on the welding end of it. But just in general, this looks like a pretty clean casting. I don't see anything secreting out of it. Sometimes you will get pores open up and it'll get oil that will seep out. In that case, what I do is I degrease it once again, wipe it down with acetone, and then let it warm up one more time, maybe 2 more times, depending on if stuff keeps weeping out of the pores. But I think we are pretty good to go here. So the next thing we're going to do is I'm going to take my MAP gas torch and I'm going to hit the base of where it appears that these cracks terminate. So we're just going to isolate that area with the MAP gas torch and warm it up a bit. And what I'm doing is I'm looking to see if that crack is going to propagate further down than it looks. So by isolating the heat in that spot, it's going to allow that aluminum to expand and contract, and therefore if the crack goes further than it appears, it's going to show us that. So right now it looks like this crack is terminating right in here on this one, and then on this guy it didn't really travel any further. It's terminating right in here. So what I'm going to do is I'm going to take a small drill bit and I'm going to go just below where that crack is terminating, and we're going to drill that out. And in this case, since I can get to the other side, I'm going to go all the way through, and we're going to do the same thing on this one right here. All the way through. Now that we've terminated our cracks with our drill bit, we are going to take our die grinder and we're going to go in and excavate one side of the crack. Now, there are specific aluminum die grinder bits, and unfortunately, I don't have one right now. I can shove a photo up here what they look like. Basically, they have a more coarser flute. My favorite shape to do these kind of jobs is kind of an acorn shaped one like this. They make pointy ones. These ones don't get quite wide enough to gouge out usually, but unfortunately all I have for this one is this big long one. So I'm going to use the little round here to start with, and I might have to switch over to the pointy one. So whenever I go to grind a crack out like this, I always like to start on the hardest side to get to. So in this case, I ground the inside of this one out, and then I ground this side of this crack out. And the reason we do that is we're going to weld one side of this up first before we gouge out the other side. So just like if you're doing a certified full penetration weld, you're going to weld out the one side and then you're going to back gouge it. So we're going to weld this up. Hopefully we get a little bit of bleed through penetration here, and then we're going to take our grinder on the back side of it after we've welded one side, and we're going to grind out all the way to the root of the weld until we can't see a crack anymore, so that we know that that crack is completely eliminated and is not going to propagate itself internally down the road with heat cycling or other factors beyond our control or understanding. So now that we got that welded up, you can see that we have some penetration on the backside, but that crack is still showing itself there. We're going to take our die grinder and grind out the backside of both of these now. See this one here? That one, the crack isn't there as much, so we had a lot more penetration. But we're going to grind all this out and groove it out to about 50% of the depth of the base metal, and then weld this side out. So as you can see, we've ground all the way through on the other side now till we can't see the crack, and we're into the base metal from our other weld. Definitely want to make sure that we build up this upper edge so when we go to grind it down, we have enough material there to have our gasket seal on. Okay, so now that we got this thing all welded up, one thing to remember is I welded this thing up while it was still warm. It's going to be easier to weld when it's warm. We have to remember that our casting and our filler metal are more than likely going to have different shrink rates. So meaning as it cools down, those materials that are now one are going to shrink at different rates. And if they shrink too fast at different rates, we can cause cracking. So what you're going to do now is you are going to put this thing back on your stove or out in the sun or back in front of your infrared heat lamp like I did. And I'm going to let it sit there for probably another 20-30 minutes. And then I'm just going to turn it off and let it cool off slowly. Or in this case, I'll probably just go set this out in the sun and let it cool off slowly. So that's going to minimize the chance of cracking or delamination within the weld. Okay, so this thing has set out in the sun and cooled down slowly. So now we're ready to start grinding and doing a little finish work on it. There's a couple things that I like to take into consideration when I start grinding and finishing something like this. First one is clearance and what actually needs to be ground. What I mean by that is on the inside of this wall here, the crank comes really tight tolerance to that. So we're gonna definitely grind and polish all that down so it's nice and clean, just like the factory. And then we're for sure gonna grind the face of this down and smooth all this out so that our gaskets seat properly and seal. But places like this on the back side of this part here, I know, since this is my part, that there's nothing that's gonna interfere with that. And since it's a nice flat, clean weld, I'm probably just gonna leave it just so it's got some more structural integrity there. And here we have it. So we got this one here and this one there, and they're all cleaned up now. So I used an assortment of things to grind this down. I started with a coarser option with the carbide. Then I dropped down to a barrel sander to get that profile. And then I dropped down to some Scotch-Brite discs on both this guy and this guy. I was able to get down in here with this one. These are great, actually. These are cheap on Amazon and they work really good. But I was able to bring that inside finish back. You can't even tell. There's a little bit of discoloration, but besides that, you can't even tell where that weld was. It looks really good. And then I got the surface ground down flat. I got my straight edges here. There's our set of machinist parallel bars, and I can slide that across there and it doesn't catch on anything. And I'm not getting any light through underneath of it. So we are flat enough that a gasket will seal that up. We're within a thousandth or two. And that's all that this is gonna require. For something like this, it's gonna have a gasket on it that's gonna be probably 10 or 15 thousandths thick. 1 or 2 thousandths is not gonna be a deal breaker. It's still gonna seal up. And if the customer wanted to after that, they could have it sent out to a machine shop and they could deck the surface of it. But this is mine, and I know this will work and this will run with my experience on running bikes and stuff. And I don't feel like this is unprofessional at all to be within a couple thou on a surface that's gonna have a gasket on it. So thankfully these welds turned out pretty clean. I do wanna reiterate, I only had to go over these once and they filled in great with the weld, but sometimes you have to weld it in and then you gotta grind those welds out and weld another pass over them and grind those welds out and weld another pass over them. And that's just what you gotta do to get new clean metal in there that's not full of those hydrogens. And in saying that, you have not failed if you have to do that. Like, you failed if you didn't finish the job, but you've not failed if it doesn't work the first pass. Like, sometimes these castings are so dirty and so bad from the factory even, not even if they're oil impregnated. Sometimes it could be due to your lack of care in cleaning or just not doing your due diligence with cleaning. But sometimes you can clean it to you turn blue in the face and the casting itself is just gonna be so bad. So don't get down on yourself. If it takes 3 or 4 times to weld it up, grind it out, weld it up, grind it out, sometimes that's what it takes for a cast job to get that new metal in there, for things to just clean up and be able to adhere properly. So I would love to hear your guys' tips and tricks for cast aluminum repairs. Leave those down in the comment section below and I will definitely read those. And if you want to see more fabrication content, make sure to click some of the links that are going to pop up here. If you want to be notified of upcoming videos, hit that subscribe button and ring the bell. It's free to do so, and go build something, guys.